Okay, oh yeah, welcome back. Welcome back to Herb's class, man, for 5 more minutes of math. So I'm sure you've already watched the video about systems of equations, but now notice something has changed. This is systems of inequalities now. Now the definition hasn't changed. Yeah, we're still talking about 2 or more, right? So we've graphed inequalities before, but maybe a quick refresher about the difference between an equation and an inequality. Okay. Quick refresh. So this is a line equation, but this has an equal sign, right? So on this particular situation, we're just talking about the points that are on that line in a row going out to wherever, right? But for an inequality, yeah, we're talking about a bunch of numbers now. We're talking about all of the numbers that are above that line. This is a greater than sign. So remember, we graph these just like we would graph a regular line. And then when we go to put our line, to draw our line, remember there are 2 options, dotted and solid. You remember what goes with what? Yeah, let's see. Good, I knew you remembered. So remember, if it's greater than or less than without the equal sign, then it's a dotted line. Remember, because it can't be equal to that line, so that's why we dot the line. Yeah, now if it can be equal, greater than or less than or equal to, then we put a solid line because then it can be equal to that line. Yeah, now remember, after we dot the line or solid line, then we shade. Remember where to shade? Let's see. Good, 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 good. So remember, if this is a greater than sign or greater than or equal to, we're talking about all of the stuff that's greater than, above, bigger than the line that we graph. Yeah, and if we say less than or equal to, then we want to highlight everything that's below our line. So we would shade everything below our line, right? Let's do a real quick one. Let's graph this one. Good. That's almost exactly what our line should look like. Now, there's one thing that's wrong with this. I drew a solid line in there just to get the line down. If that were an equal sign, that's what my line would look like. But it's a greater than sign without the equals to. So, yes, that line should be a dotted line. Yeah, and now if we're talking about all of the numbers that are bigger than this line, greater than this line, I want to shade above the line. Now, some of your lines may be tilted in a way where it's hard to tell, but above the line, yes, just like that. Now, in an inequality, this is called a solution space. Yes, it's called a solution space because any point in this space should work when I plug it into this inequality right here. For example, -4 for my x value, put a -4 right here. Let's talk about what we get. Good. So when I plug in a -4 into my equation, I get out a -5. So what was the y value? 1, right? Yeah, exactly right. So if I replace that y with a 1 and I replace that x with a -4, does this make sense? Is 1 greater than -5? Yes, yes it is. Every point in this shaded region is a solution. It's called a solution space. Now, what if I give you a point on the line? Let's try this one. 0, 3, right? Okay, so let's plug that in. Good. So I put in my x value of 0, 2 times 0, 0, 0 plus 3 is 3. What was my y value here? 3, yeah, but is 3 greater than 3? No. So that's why this line is dotted. Points on the line, if it's dotted, won't work. Now, if it was a solid line, if that was or equals to, then we would have been good. But that's the whole point of this dotted line. Yeah. All right, let me show you what it looks like with 2 inequalities up here. Okay, yes, those look like equations we can work with. So let's graph these equations, right? So we'll graph one at a time. Let's take the first one. I got an intercept of 0, slope of 1/2. So starting point, 0. Yeah, exactly right. And now from that 0, I'm going to count up 1, right 2, draw my line. Yeah, solid line because it's or equals to. Exactly right. Yeah, good, good, good. Now, let's go ahead and shade now. So I'm shading above this line. Good, 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 good. That's perfect. Okay. So now let's go ahead and graph the other line on this same picture. Now, if that's at y equals 3, remember what that looks like? Yeah, horizontal line at y equals 3. That's awesome. Very, very nice. And I dotted it because it's not or equals to. Good. Now, where am I shading? Am I shading above this line or below this line? Below. Yes, just like that. Now, before our picture gets too complicated and crowded, this is what I want you to look for. What part of this picture did I double shade? There's a part of this picture that was shaded twice. Can you find it? Yes, that's the part that was shaded twice, right? I shaded above my first line and I shaded below my second line, and two of them shadings overlapped. Yeah. So in a system of equations, the solution space, if there's more than one equation, is yes. The solution space is the double shaded region. So what that means is any point inside this double shaded region will be a solution to this system of inequalities. Oh yeah. Man, I hope this helps. There'll probably be some practice after this. You should probably check it out. Until next time, bye guys. Oh yeah.